All right, this next problem we want to use synthetic division to solve. And looking at this problem, it looks like we are missing a few terms. So if you'll notice, we have a 3r to the fourth as our biggest term. So that means I need to have an r to the third term, r to the second, a single r, and then a number constant. So you got to go 4, 3, 2, 1, 0. 0 r's. And if you look at this problem, we have a 4, we have a 3. We do not have the 2 term, so I'm going to need a 0 as a placeholder. And then we have the 1, and we have the constant term. Okay, so this time we're looking at the linear factor r minus 3. We're going to set this equal to 0 and just find out what the 0 is, what the number is. So I'm going to add 3, or you can just see it's going to be the opposite. This is going to give me r equals 3. R equals 3 is the number I'm looking for. That's going to be my box number. I'm only focusing on the coefficients with synthetic. So I'm going to put 3 in my little half box. From here, I'm going to write only the coefficients of my polynomial. So I had a minus 11 in front of this one. This is going to be a 0. My single r is going to be a positive 16. And then my number was a positive 15. Okay, so I'm only writing down the numbers. So I have a 3 first, then a negative 11, then a 0 as a placeholder, then 16, and then 15. Okay, you skip some space, draw a line all the way across, and you start with the first number, your coefficient, you bring it straight down. Always bring it straight down. And then from there, every number below this line, you're going to multiply by 3, write it in the next column, and then do the math. So I'm going to do 3 times 3, that's going to give me 9. Subtract, because they're opposite signs, negative 2. 3 times negative 2, negative 6. Add these, I still get a negative 6. 3 times negative 6, negative 18. Combine these, that will give us a negative 2. 3 times negative 2, negative 6. Combine, we will subtract, and that will give us a 9. So the fact that we did not end with 0 means it's not a factor. However, we want to write the quotient, and we want to write the remainder. So the numbers that you have are going to be a part of your quotient. Just like what we started with, we have a polynomial with r as our variable. Dividing out 1r from our linear factor r minus 3, but we just used a number, we're going to reduce this power by 1. So instead of starting with r to the fourth, we're going to start with r to the third, because we divided 1 out by this process. So this 3 means 3r to the third. Minus 2 means minus 2r squared. So just again counting down. Then I'm going to have a minus 6r, and then just a constant term, minus 2, and then this 9 is my remainder of 9. So my quotient, I'm looking for 3 squared minus 2 minus 6 minus 2 with this remainder of 9. So A looks good, that's to the fourth. That doesn't have the remainder, and this does not have the correct signs. Okay. Another one, they want us to do the same thing, synthetic division, write the quotient and remainder. This time we have several more missing terms to add to the mix. So we have x to the fifth to start with, so I need an x to the fourth, x to the third, x to the second, single x, and then a number. So we have an x to the fifth, we do not have an x to the fourth, we have x to the third, we do not have an x to the second, we have a single x, it's negative, we do not have a number, it's going to be a 0. So we got 1, 2, 3 missing terms. The rest of them look like to have a coefficient of 1. We're going to find our box number. So it's going to come from the x minus 4, set it equal to 0, and you get x equals 4. So 4 is going to go in our little box. I'm going to write the coefficients of this polynomial down. So just understood 1, 0, understood 1, 0, a negative 1, and then 0. Draw a line, bring the first term straight down, multiply 4, add, we still get 4. Multiply 4 times 4 gives me 16, add 1 gives me 17. 4 times 17, 28, 68. Add, we get 68. 4 times 68, 240, 72. Subtract, we get 271. And then 4 and 2, 71. So let me just check some of this math. It's starting to get really big, really fast. So 4 and 68, let's just double check. And then we're going to do 4 and 2, 71. 42, 71. So we get a 42, 71, add, we still get 42, 71. So again, we didn't end up with 0. It's not going to be an even polynomial. We started with a degree of 5. We're going to drop that by 1 and start with x to the 4th. So this 1 just means x to the 4th. And then it's positive, so plus 4x to the 3rd plus 17x to the 2nd plus 68x, and then plus 271, and then your remainder is 4271. So quotient, we're going to type it here. And 4271. One or more responses incorrect, so let's double check. So they like this. They said that's good. So now 4271, not okay. Let me double check that. Let me see, how do we get, oh, I think I just typed in 4271. I'm going to do 4 times 271. That's what it is, 4 times 271. I didn't even notice I did that. 1084. That is my error, typo. 1074, make sure. Yeah, I think I just typed in 47271, didn't type times. So this should be 1084. 1084. Okay, so just be careful. That's my biggest error, and I did it again. I typed a 7 instead of an 8.